Thank you. It sounds like this is on. Very nice. Welcome everyone, and thanks for inviting us to the host. It's fantastic to be here in Gothenburg. We had thought a bit about what we wanted to talk about today, and a lot of these things we come out and talk about are very technical in nature. Today is going to be focusing a lot on resilience and some processes that we do in the NGO that we work for. This is Georg. He's going to introduce himself.
Yeah, hi. I'm Georg. I'm working nowadays on the so-called network health team. We will talk about some of the topics we've been dealing with lately in the upcoming talk. Previously I've been working on Tor browser for many years, but now I'm going more to the network side. And yeah, Alex. My name is Alex. I've been with Tor since 2017. I'm based out in Copenhagen. In my daily job, I'm heading up Tor's network team. We work a lot with Georg and his team. And our responsibility in our greater ecosystem is on the anonymity side of things. We're going to be talking a bit about some of the things we do, even though we won't be able to have time to touch sort of deeply into all of these things. In my spare time, I'm also one of the event organizers for the Danish hacker camp called BoyneHack. So how many people in here have heard of Tor? I suspect that's a lot of free software conferences. Okay, almost everybody. So to most people, we are an online anonymity and censorship circumvention tool. Everything we do is free software. The network we have is an open network, meaning that everybody can both use it and can participate. We do all of our specifications work, such as like protocol design and so forth, in the open space, and everybody can contribute. You can come in and see when we're discussing these things. You can contribute with feedback when we make potential mistakes, ideally before we make them, and so on. We have a pretty big community of academic researchers who's helping us with various topics, and other engineers and people who aren't necessarily working as staff on the Tor project. And we of course also have developers, all our users. We have between 2 to 8 million users of the Tor browser every month. And then we have our relay operators, which Georg will talk a bit about later. Since this presentation is going to be about resilience, it is worthwhile to notice that we are a US-based 501c3. The 501c3 part is mostly a tax thing, but it will become relevant also later. So if we zoom a little bit back about what it is Tor is, for the few people who didn't raise their hands when we asked what Tor is, a lot of these things we do is we ask ourselves what is an attacker can do in various situations that we're doing. One of the simplest things here is that we have a very abstract anonymity network in the middle, represented by this cloud. We have a number of nodes participating in the network, annotated with the R1 through R7. And then we have Alice and Bob, who's trying to establish a secure, anonymous connection between each other. And very often so, the things that we're trying to do when we set up different things is that we try to ask ourselves, what can an adversary do, like someone who wants to do harm to Alice or Bob, or both of them? And in this case, trying to de-anonymize them. Like, is the adversary able to monitor the uplink from Alice's computer into this abstract anonymity network? That would be the equivalent of, an ISP in our part of the world, or it could be a state actor who's able to see the edge flows coming out of a country in certain more restricted jurisdictions and so on. It could also be that the actor is able to operate parts of the network. It could also be that an actor would be able to operate the entire network. And that is some of these things that we will touch base on also a bit later, that we do not think that is possible. It could also be that the adversary can see the other end of what comes out. So in this case, see that Bob is connecting or receiving connections from the anonymity network, but I have no idea about Alice's side. It could also be the adversary is the one that Alice unfortunately is trying to communicate with, which will be very difficult to deal with in most circumstances. This could be, for example, that you're trying to reach a website that actually wants you to do harm, and you are interacting with it through an anonymity network, where, for example, you log in using your normal real-life credentials, and that does leak your identity. This might give you some benefits. If you don't want to reveal your IP address or where you're located, then maybe that is okay. It's important when we talk about anonymity that it isn't just encryption. Encryption has become a very big thing that we talk about in general, and encryption protects the content of the data. It doesn't reveal, it doesn't, like a TLS session won't hide, for example, which web server you're connecting to. People who know a bit about TLS will know that there is SNI and so on that can reveal various metadata about the connections while you're trying to establish it. A big thing we do in addition to
the anonymity side is also the access side. This is the part that we call anti-censorship tool. We build tooling and various kinds of infrastructure for people to operate this tooling and make it easy for people to connect to it. This slide is something that we particularly like to use in this part of the world. It shows a lot of websites in the aftermath of the Arab Spring in around 2012-13, and it all has these sort of vibes of cartoonish and looking a bit funny and ha ha ha. But it is something that we also see in different forms and shapes in our part of the world. This is the Danish blog site that is used particularly it started out with being the big Pirate Bay case in Denmark. Later it got extended to all of MP3, then the pharmaceutical monopoly enforcement and gambling monopoly enforcement and so on has become a part of it. So a lot of it is related to these, you see this Rettighedsalliancen in the bottom, which is the Danish sort of copyright owners association who's part of running this, together with the state, together with the ISPs. And of course it was also by to the politicians under the label of protecting children from children's sexual exploitation material, which is often used in these contexts for sort of pushing various agendas. One of the things we know from some of these Snowden revelations is that the Americans have been very open, and it is not only Americans, but many different entities in the same way, is that we kill people based on this metadata. So the metadata problem is one part we know from the anonymity side that we should care about. The network anonymity cannot stand on its own, and that was something that the Tor project found out relatively early in the phases, and that is why the big product that many of you will be using will be the Tor browser. What we try to do with the Tor browser is that we try to encode some of the problems that we identify over the years. There's still problems to solve, there's problems that have been solved, but application-specific problems that exist in a browser. This could be, for example, that you're leaking information about which fonts you have. It could be various fingerprinting options that exist in some of the modern GPU acceleration features that is in browsers. It can be WebRTC leaks and so forth. We, in addition to the Tor browser, we also recently merged with the Tails project. Tails is a Debian-based live Linux distribution which tries to do a lot of the things the Tor browser does for HTTP and the web, but do it for a full-blown operating system where everything is going through Tor, with the exception of, when you are on a network like this annoying one here, where you have to authenticate with a username that we all share, then Tails have a little widget for sort of bypassing these things. Tor browser is something we've been running for a while. It started out as being a bit like an extension that is predating my time, but today it's a product that you download, install on your Linux, Mac, Windows computer, and can use in the daily. One of the things that we are really happy about with the metadata question and the anonymity side, like the metadata question alone, not with the anonymity side, is that there's other vendors out there who started to sort of care for these things and have started to actually give a shit about this problem. Mulvel, who's based here in Gothenburg, they have recently started collaborating with us. They're funding part of our work on Tor browser. So essentially what we're doing is that we have now a base browser, and we have which is Firefox with all the anti-fingerprinting tooling and so on applied. And we then take that, apply some Tor branding, add the Tor component, all the anti-censorship technology, bundle that to Tor browser, and then we build the Mulvel browser, which is the base browser with the Mulvel branding on top of. So this is really, really useful to see that it's not just us who's sitting, in a basement somewhere trying to solve these problems. It's also something other people are caring for. And fortunately, it's also something that gets a lot of academic attention right now. We as a community have an interest in also building an ecosystem. One thing we've talked a bit about so far has been sort of, you have a web browser, you connect through the Tor network. We also have something called onion services. Onion services is essentially anonymous services where you have a Tor instance running on your computer, and you expose a local web server running, and then people who has a Tor client installed is able to reach them. They have some pretty desirable properties for people, especially for folks who are behind NAT networks, where you often so cannot run services, in that they are sort of connecting out into the Tor network, and then you meet inside of this cloud that is in the middle. There's a lot of different organizations, amongst other Freedom of the Press Foundation. They do a lot of work on whistleblowing tooling for journalists and for source protection. They've been building a lot of tools around this onion services as part of the Tor system. One of the big ones is SecureDrop, which I believe if you look at some of the Swedish news outlets' website, many of them will probably have a SecureDrop instance or will refer to different ways where you can communicate sort of securely through these services. We also, as an organization, try to sort of run our own code and try it out. We run our own onion services, so all the different tooling, all the different web services we have, if you're interested in reaching those via onion services, then you can go to onion.torproject.org and see like a big list of these features, of these sites. I mentioned that we wanted to talk a bit about resilience. One of the things that we have to sort of look a bit at when we talk about resilience is also critically look at what we are doing ourselves. Tor started as in the 90s and sprung out of some academic research on onion routing. That's what Tor stands for, it's the onion router. And the code base is starting to show its age. It's this very old school Unix daemon thing. It's more or less 5 different tools in one binary. It has a ton of global state, like it has global variables and so on, that it makes it very difficult to embed into libraries and use for different applications. And we identified in 2018, when we got a big grant to work on mobile, that this was just not feasible down the road. We managed to get it to work, it sort of works. iOS has some problems with that was memory related, but all the integration paths are not very pleasant. It's very difficult to restart Tor and these kind of things. So one of the things we started out was a project that we call Arty. It's a Rust implementation of Tor. We are trying to build it as a lot of small components, different libraries that you can use for working with the entire ecosystem. We do a lot of data analysis. That's actually more Georg's team that's doing a lot of that. And you will see a lot of visualizations later and so on. That is all has to do with parsing a lot of different kind of objects that exist in the ecosystem. And that is all of the things that we're trying to contain in Arty, while also making it possible to have onion services, be able to use it and so forth as a normal client. And all of this while trying to avoid the spaghetti architecture that we have right now with the C implementation. There's a bit of a meme in our communities with this thing with just rewrite it in Rust, and a lot of it is mostly for fun, I hope. One of the things we have that we identified with the network team was that we try to track security issues or something that we call a trove. It's a bit like an internal, not invented here, kind of CVE, where we have some different parameters that we can track for different classes of security bugs that are more specific to our domain. It's almost like a sort of self-containing security tracking system. We could see that 21 out of 34 of the troves we had were all related to issues that comes from issues with these sort of memory handling in C programming language, in the C programming language, and that would be significantly more unlikely in Rust. One of the things that also played in was that while hiring, we are an NGO, and it's significantly easier for C programmers to go out and find really jobs in the industry. And we had sort of a lot of folks in the team who were very excited about moving to Rust and trying this out, and for hopefully be able to iterate a bit faster with the features than we've been able to do with the C code base. Our development process is entirely happening in the open. Most of the things happens on the OFTC IRC network. Everybody can join our channels. We have recently started adopting matrix integration, so people can connect via the matrix bridge that exists, and we exist also with our channels on the matrix.org namespace. We run a it is possible to sign up and request an account there and start working on all the different projects that we have, both the sort of core components all the way over to the browser, to the services, everything that we're, all our policies and so on also exist there. We have a sort of, we stem a bit from the cyberpunk movement in the early days, so we also have anonymous access to our GitLab. We built a tool called Anonymity, where you can interact with issues or even create issues, create security bugs without signing up as a user, where you basically get this authentication token that you store somewhere on a piece of paper or write it down or bookmark it or whatever, and then you're able to interact with the developers without having to reveal your handle. This has served to be particularly useful for one-off feature requests or bug reports, but we also have people who swear to using this tool. And we do think it's interesting to have this anonymous angle to an ecosystem when we are building anonymity tools, right? It does come with the price. If occasionally there's abuse, and we have built the whole thing around like pretty tight moderation, where we have folks internally who can sort of review if this is bullshit that someone is sitting and writing, or it needs to be filtered through, and the different engineering teams can start interacting with it. Until the corona hit, we had these cycles of meeting once every half year, roughly. Somewhere physically, but like everybody else, we were panicking a bit about what are we going to do. We're not going to see each other. That's where all communities sort of meet up and take the temperature of the room and figure out that we are actually human beings and well aligned and so on, and not just have a lot of discussions online. We started having significantly more sort of audio and video meetings that are happening, but many of these end up with a set of action items that has to do with people are reporting back on tickets, people are updating ticket state from these kind of things. So there's a little bit of things that you might miss out on, but we do think that these things have absolutely been worthwhile in terms of the sort of efficiency for how well we're collaborating and working together. For RD, we do it in a way where we, once a week, have every 14 days we have a pretty boring internal meeting where we talk about a lot of brand management and so forth. And then offset by 7 days, every other 14th day, we have a public one where everybody can join, also people who's trying to integrate with our tooling, or have questions, or have feature requests and so on, they can join in and chat with the engineering team. We have a significant amount of work that goes into our protocol specifications. You can go to spec.torproject.org and see these fairly nicely formatted specifications that we have. This entire process is also happening entirely in the open. You can subscribe to our Tor Dev mailing list or follow the GitLab issue trackers for these kind of things. It's how people internally, when we start thinking about that there's modifications we want to do and we need to sort of rationalize why we're doing it before we start going out and request funding for it and figure out whether it's even possible to do, things start their life off as a proposal where people write down, here's the reason why we want to do that, we write down the description of what it is, and we give a summary of it, and then it gets included to this Git repository. And unlike the IETF RFCs, where once they are published, you sort of have to counter them with another RFC, and then someone 20 years later have to counter that one with a newer RFC, and so on. Then these are more live documents. We don't have many different implementations of Tor right now, so we can sort of live with that these things are a bit more dynamic in nature. Everything starts their lives as a proposal, and often so ends up in one of these specifications. Once it's implemented, things get merged. So ideally, when you begin looking at implementing some of these things, you only have to read these specifications, and then ideally, the longer time you're involved with the Tor community, you will learn a lot more about the different proposals and what is happening there. We do get significant amount of help from the research community with these things. There's Tobias Puls here in Sweden has been doing a lot of work on padding for the different connections where you add different kind of data patterns on top of the flows that you already have to try to hide what is actually happening inside of an encrypted data stream. So that is fantastic. We would not be able to do these things without that collaboration. One of the things that by now has started getting more normalized is the reproducibility of the builds. One of the things we often have in the free software movement is that we are sitting and programming stuff, and then we publish a topple somewhere. And that is the source part, of course, but the thing a user is using is often so the binary. And between getting from the source to the binary, there's some kind of build step where you run a compiler, or you generate some documentation, or whatever. There's often so some kind of transition there. The nice property about these sources is that they are verifiable. We have Git, we have checksums we can look at, we can do a diff of the source code we have downloaded. And the nice thing about the binary is that it's actually usable. The source code in its own is nice for sort of figuring out what's going on, but it's not so nice in terms of executing. So there is sort of a missing piece here with the build step. And traditionally, the way the work we have been doing with the entire build process for the binaries that people would be downloading would be that someone who's doing the releases will fetch the source code, verify that it's correct, build it, sign it, and publish it. And then at the other end of it, you will download it, verify it, install it, hopefully be happy. The issue here is if the build part is compromised in some kind of way, where an attacker is, for example, modifying the person who's running the build process computer, or there is a malicious compiler, or there is some kind of backdoor in this part of the chain. So one of the things the reproducible build system does is that it allows us to have multiple people running the entire process, and then we verify together at the end, thus allowing us to sort of secure some form of integrity in this kind of world. It is quite a bit of work with getting some of these things to work well. We have a very nice tooling around our browser builder that allows for other people, such as yourself, to try to really relatively quickly build the Tor browser binaries for all the platforms very easily on a Linux computer. And that is something that has also made the development life a lot easier when, for example, my team needs to test something with a Tor browser, even though we are not traditionally used to working with the browser source code. The reproducible builds work today, I believe it was originally sort of pioneered by Tor and the Bitcoin community. The Bitcoin community started to get a little bit worried when things started getting very valuable, because suddenly there was this, like if I mess up some code and somebody loses $1 million, that's not so great. Or maybe it is great. But that was a big part of it, right, for trying to solve these things. There's a lot of the Linux distributions today, the Debian project, I believe the Arch Linux project, I think is having quite a lot of attention to these kind of things. So there's a lot of people doing fantastic work in this space. They do have gatherings occasionally, so check out reproduciblebuilds.org for that. One cool thing we do is we have also reproducible source releases. That means that for CTOR right now, the way it works is that we need to have bit-by-bit tarball that are identical that multiple people can generate. And we then have this CI pipeline that also validates things. This has the benefit that because of the way PGP signatures from the privacy guard tooling works, we can have multiple people signing the releases without them relying on downloading any materials. Everything can run on their local computer just with the git checkout. So that people, for example, who knows me, have my checksum, or have my key in the keychain will be able to validate the Tor releases. And people who know David or Nick, who's the other release managers, they will be able to validate it using the keys that they need from that. And now I will pass it on to George.
Thanks. Thanks for the overview. We talk a bit about other parts of the resilience question, and I want to start with the network one. So when we talk about the network being resilient, what do we actually mean, and how can we enhance this state? So there are two different big topics I want to talk about in the coming minutes when we talk about the network resilience. So there is one of the things what we actually want to avoid any disruption in the network, or that the network is getting unreliable, because that is obviously harming users in various ways, not just performance-wise, but it can have anonymity implications as well. So, but that in turn comes with the question: what is actually meaning when we talk that the Tor network is not having any disruption when it's running normal? It's not so easy to see. And then if we have potential disruptions, the goal is to detect them quickly, and not just that someone is coming on IRC or so and saying, hey, you know, your network isn't running reasonably well, please have a look at that. And ideally, we want to caught those things preemptively, so that's not really happening in the first place. But when this is happening, actually, in the network, then we want to get this mitigated early on. So there's kind of a negative component here in the sense that we want to have an absence of disruptions so that the network is functioning pretty well. And the positive part is that we want to have a network which is diverse in a lot of senses. So has to be distributed trust. You saw the early slides Alex showed when we were explaining how Tor is working with the different relays in the path. This is pretty nice. You don't have a single point of failure. You have a bunch of relays where your traffic is running through. But there's more to this question we'll see later on. And then we want to have different sets of relay operators. Right now we have thousands of them, and that's pretty cool, because if just Alex and me would be running the Tor network, it would not be so nice. And we would not be a diverse set of people, basically. Additionally to the operators, it's important to have really the different locations, jurisdictions, having different operating systems and so on. You see later on how this is currently handled and currently what is the state of the art of that. So those are the big topics we talk about when we talk about network resilience. So let's look let's look at some of the fancy graphs we have. So you see here a graph from directly connecting users from Lithuania, which has some interesting properties. So keep in mind that Lithuania has around like 3 million inhabitants, you know, and at some point there was supposed to be 1.5 million Lithuanians using Tor at the same time, which would be nice in theory, but it's clearly, you know, not the case. If you look at the flat part of these graphs, there are usually like 20,000 users concurrently coming from Lithuania. So that's clearly an anomaly. We can see, okay, maybe there's something going on in the network. So that is an obvious case. But what about this one here? This is almost a pretty flat line. What do we do with this kind of data we have? You see again, this is from directly connecting users, which is interesting for another reason, because while we are talking about network resilience, there seem to be data points outside of the network which are relevant as well to help decide whether the network is in a good shape or not. In this case, it's normal clients like you and me using Tor browser or whatever. So there is a wider set of data points we have to consider here. So yeah, for that one, it's pretty interesting because you see in the lower right corner, around 25, March of 25, this is the flat curve. And if you just look at a larger time frame, you see, this might not really serve as some kind of baseline or a state of normality from directly connecting users to Tor. But even if you look closer at the past, you suddenly have a really big mountain in the middle of this graph here. So what do we actually do when we try to determine whether the network is behaving normally? It's not so easy as we see. And even if you look closer at different kinds of graphs, this one shows the use bandwidth right now, which is the purple graph, and the bandwidth which the relays advertise. And normally you would be pretty happy to see that both graphs are rising. The purple is okay, but for the green one, the problem is that this is likely caused by some malicious actor being in the network right now. We are dealing with them. So while we usually want to have those increasing curves here, because then we see that there's more bandwidth available or that Tor is used by more people, it can be easily deceptible that this is just basically fake news and not really a natural and good and sustainable growth of the network, but essentially an anomaly which we have to deal with at the end of the day. So what we've been doing recently is we are setting up a project which we call the Exception Reporting Framework Project, which is trying to figure out what could we use as baselines for metrics. One, when is the case that the network is facing anomalies, and how do we report this? How do we have alerting so that the right people can do close investigations and that we can do mitigations? So we want to have a lot of sensors in the network, so-called sensors, to collect data at different points and have a system established which is doing some anomaly analysis automatically with the help of the regular network health analysis, and then is triggering some alerting monitoring systems so that the right people get informed. And at the same time taking past incidents into account so that we can see, okay, we saw this kind of DDoS attack in the past, this is, those metrics were relevant back then, and maybe that's the same kind of attack, so that we get some help with doing the mitigations part. We've been talking about the GitLab stuff. This is how it looks like. If you're interested in this project, you can click on the link here or just visit this GitLab site. There are some ideas what we want to do, what we plan to do, and this will cover the next 1 or 2 years, depending on how it goes. Another part of this framework thing is that we obviously want to have some mitigations, and There are different teams at Tor. Alex already said some things about this. There's network health team that I'm working on. And that one is at the center of this kind of coordinating those mitigations in case we need them. But there are other stakeholders, like the network team itself, the community team, because the relay operator community might need to be informed or might test patches out. We had this in the past already, where we collaborated with those folks and they were giving us valuable feedback and debug information. Or they are just the user community that needs to get informed that there's something weird going on and they might need to get advice. And then there are the bad relays team as well, which is responsible for hunting bad relays and getting them kicked out of the network, and what we call directional authorities, which is a group of special relays and operators I'll talk later about, because they have to apply some of those changes, for instance, getting relays from the network. And obviously you want to have some kind of evaluation about how we did, how we mitigated problems so we can do this better in the future. So for the directional authorities, if you look at the relay search, where we have published a lot of useful information about the relays running the network, you see there are kind of 9 to 10, depending on how you counted those folks, because they have the authority flag. So those flags are given by the directional authorities. Basically, they are roles the relays have in the network. If you run a relay which is at the end of the path, this is called an exit relay, which is making connections, for instance, to google.com, and it's getting the exit flag. And then you have this shield icon here, which is for guard relays, and those are the relays which are the first hop in your path usually. So a lot of those icons have special meanings, and the sun here, I suppose it's the sun actually. This is the flag for the authorities. And you can ignore the search relay with the nickname search, but the other 9 ones are so-called directional authorities. And the important thing for those folks is that they act as the kind of the trust anchor on the network. So they should be diverse and run by different people, and this is kind of the case. You see there are some run in the US, there are one in Austria, some in Germany, in Sweden, and so on, and they are run by different people we trust. And what they actually do is they make and maintain a so-called consensus, which is a view on the network every hour. And this is important so that every user and every relay is getting the same view on the network to help with an anonymity set and attacks against the anonymity of users. But they are special relays in the sense that they require special trust because of their power on the network. And they have to do a bunch of things to be good directional authorities. So they have to keep their authority running. That means they're really running and properly running, not just barely running. They have to be responsive as well, so that when people on the network health team come to them and, hey, look, you have those bad actors in the relay crowd, please get them out of the network because they might be stealing bitcoins or whatever they are doing, those exit relays. Then it would be good if those directional authority folks would respond in a timely manner and apply the changes in a timely manner, not just wait a couple of weeks and months until this is happening. And they obviously have to have some kind of integrity. That means that they are not easily coerced by law enforcement agencies or whatever folks want to coerce them into harming the network. And they have, at the end of the day, as their task as well, helping with the trade-off between maximizing the network capacity, because that was helping with user performance and so on, and on the other hand, the dealing with bad relays, because oftentimes it's not so easy and clear-cut that this is a malicious actor or this is a bad behavior, and then we have to figure out how we deal with those folks. If you're interested in this part, you can look at the directional authority expectations document. We have formulated this pretty recently, and there's more about the role of the directional authorities. If you look at the diversity angle from a different point of view, just looking at the relays you have on the network, you don't have to count all of those onions here. I mean, this is not the goal of this slide. Don't be worried. you see, this slide is showing you the exit relays, and the important part here is it claims there are like 50. This is not on the. It's cut off. That's unfortunately okay. There should be at the bottom of the page some line of text saying there are right now 54 countries where we have exit relays, which is pretty nice. You know, if you look just at the number, it's just not, you know, 1 or 2 countries, but it's 54. It's not bad. But then if you look closer, you see there is a lot of relays here, and clustered in particular countries. So those large bubbles here, like the 10 or 12 bubbles here, are not just single countries, but they are additionally all located in Europe. So it's not just a problem that there are some countries with a lot of exits, but it's a problem as well that you have a lot of those big bubbles in one single place, basically in Europe. And so we have to think a bit about diversity, what we actually mean, where we want to move forward to, because it's not so easy to figure out. First of all, what is actually important about the diversity point. It's important to have a relay in each of the countries of the world, or is it important to have just the fastest one somewhere else, or how do we structure this? And then additionally, how do we design this in a way that is that the network gets maximum resilient? Like, how do we measure diversity at all? And do we have some reasonable baselines on that? And then if you look at particular properties, should we focus more on operator diversity? That means having operators coming from different countries, maybe different backgrounds, or doesn't it matter too much? Maybe you should look more at relay country diversity, like where are the relays stationed, or what operating systems they are using, and so on and so forth. So we have part of those questions lined up for the expectations reporting framework. But I suspect this will come afterwards, a bigger project on its own, because it's not so, as I said, it's a tricky question to answer, but it's an important one. Nevertheless, what we did, we worked pretty hard with the operator community in our last project, because we realized they are key to a bunch of things we want to achieve in the future as well. So they are running the network, you know, and that's why it's pretty important that we have them in our discussions and in our decision-making appropriately represented. So what we did, we created some process for showing them a framework where they are supposed to work in, which you call the relay operator expectations, like what is it you are expected from us when you start contributing to the network. So giving them some guidelines. And then we have a proposal process similar to what Alex was talking about, but for network health improvements, where the relay operators are key stakeholders, where we get input from them and not just rule them over, and they have to apply stuff which we think is important. And what has been a particular success story is the operator meetups we have regularly, both virtual and in person, where we come together both from the project and from the wider community and the real operator community, talk about ongoing things, questions, problems, so we can get those things in the right channels addressed, and everybody's happy at the end of the day. And at the same time, we are strongly encouraging collaboration within the operator community themselves or itself, because it should not be a top-down thing where the whole project is saying something and then the community is acting, but they should try to build trust path and trust within the community itself, because at the end of the day, this will make the network stronger and more resilient. For more of this stuff, I have put a link here as well, where we have something written about the expectations I talked about as a starting point. So finally, for the last couple of minutes, just talk a bit about the project resilience itself. I mean, this is a topic which is pretty new. I don't recall in the past that we talked much about the project itself, but given the recent geopolitical circumstances, it might be smart to start talking about not just the Tor project in particular, but about NGOs and free software projects in general. What is the problem with those? How can we make all of those and the whole ecosystem more resilient? I think overall, we have been talking a lot about software code and the community context and the network. I think for the project, for those projects themselves, a lot of those things we identified as remedies work for the Tor project in particular pretty well. We think diversity is key as well, I mean, both from developer background as location of developers and tooling and whatever you're using for writing your software. This is important. Particular openness and transparency is important, so people can audit our code. They can look. If you look at the project itself, that we have an easy and low entry barrier to be part of the project too. There's community building, which is important part as well, not just within the project itself, but as I said, reaching out to different open source projects, particularly the information freedom movement part, where we see trouble maybe in the future, building common strategies, learning from mistakes, building plans, working closer together, so that at the end of the day we enhance the trust not only within the project but in the whole community, because it makes us stronger when the community is stronger. For the funding part, I have brought a slide with me to show you how this is looking like. So there are some parts it seems to be cut as well, but not the important parts. So this is how the Tor project revenue mix has been developing over the last couple of years. You see some important things, particular, given that we are talking a lot about, state-based funding and these states as potential threat actors regarding Tor. We have reduced greatly the reliance on government funding. And government grants means, at least in the past, mostly the US-based funding. So if you look at the financial year 2022, there was almost half of the budget we had that came mostly from the US, and we greatly reduced that to 26%. I think from the US itself, right now it's around 21%, if I have the numbers correctly. There are other state government grants, but that part I think is a good development, in particular as the individual contributions from people like you and other industry folks went up. So I think having a really good and diverse revenue mix for your project is really important, because at the end of the day, infrastructure has to be paid, and developers have to be paid, and so on and so forth. So that is the thing I think we do pretty well at the project here. And we are, as we are non-profit, we are committed to financial transparency. You can find all our audit reports and the 9090 form, which is the tax form in the US, on our reports page. So this is getting updated. You can see where the money is coming from, where it is going. I think this is important for having trust in the Tor project. So I won't like to miss this part. Even though the reporting is a bit delayed, but you be assured this will come. Right now I think we are at 2022 or so for the financial year. Finally, there are more indirect threats for nonprofits to funding or security as well. You find all those foreign agent style laws around the world, in Russia also. But then there's stuff like the so-called non-profit killer plan in the US as well, which is known as Bill HR 9495, where NGOs can be put into a place where they are supposed to finance terrorism or help financing terrorism, which is a pretty opaque process. So basically anybody could be targeted by that. And the problem with that is that you would lose your non-profit or 503 status, which might interfere with the individual contributions, because then they can't be deducted from taxes anymore, and it might just lower the amount of money you get that way. That's one of the problems here. So luckily right now, Tor is not affected by that yet. But there will be the next couple of years where we see how this is going, and we might actually be wary and prepare for scenarios like that, and organize with like-minded groups and different projects who have the same problems at the end of the day to be resilient to this kind of threat as well. All right, folks. Finally, how can you help if you want to do that? There are a bunch of things you can do. You can hack on some of our projects, fix bugs, and just use Tor and try to open some of the research questions I pulled up, and we have a ton of others if you think those are not the ones you want to look at, if you want to have others. You can run relays as well and teach about Tor and privacy in general. Everything is really helpful in this context. Okay, I think that's all from us, and I think we have quite some time for questions.
I have a dozen questions, but I think the most important one I might be able to ask you today is the following. In the current context in which, for example, the Swedish government is moving towards the strange policies regarding, for example, end-to-end encryption on applications and so on, what do you think the people behind, and especially the NGOs behind those applications, can learn from the resilient policies on the Tor project?
I can say something. I don't know, you mentioned the Swedish government here. I have not paid attention to that detail. Maybe it has been happening while I've been on the conference train the last couple of weeks. But one of the things we've seen with in the UK, where there's been the recent thing with Apple and their iCloud encryption and so on, there is some interesting dynamics going on there, where it seems like every time these things happen, when civil society organizations and NGOs do a pushback on these things, we do tend to find ways to make this happen, right? We saw it also with chat control and so on in the European Parliament. So I think for both us that's working in these NGOs, and we care about, a tiny little subspace of this grand problem that exists here. I think the most important thing is join your local groups. I know in Sweden you have, what's it called, DEFRI, or I don't know how you pronounce it, that's how I would say it in Denmark. They seem to be on the mailing list discussing these kind of things and would rally to action when there's things. We've been fighting pretty significant things, even from the copyright mafia around Europe. So it is important that people organize. It's important that we're sort of clever and competent in these kind of spaces, and that we go into these things and try to fight it right every single time it happens. And it will happen again after that. It's ongoing forever. So I do think that is the most important part. Specifically with the Apple thing, I found it very fascinating, and that's more my personal opinion, that Apple actually decided to pull out of it when the UK said, like, hey, you have to give us these things, and they just said, that's fine, then we disable these things for the users. We're going to have a much more sensible, democratic conversation if we in our societies actually end up having the companies to say, okay, that's fine, we don't want to play this game, then we just go out, and then people will start seeing like, okay, there was something and we'll hopefully fight more for it in the future. Want to add something?
No, that's fine.
So, yeah, I'm curious about the Tor browser, and Daniel Stedman also mentioned with the kind of monoculture in browser choices. Are there any talks or ideas about building your own browser as well?
From scratch?
Yeah. But we only have Firefox and Chromium based. Would there be a third option?
Yeah, we have been investigating this space for years, particularly Chromium-based browsers, because one could argue that the Google-based browsers, at least on the performance and on the security side, are outperforming Firefox and the Mozilla-based browsers. And just to give the users a different set, because it's kind of a resilient part as well. If you have serious bugs in Firefox, you could easily say to users, hey, use Chromium-based thing for a while. You have right now, if you have different options, different code bases, that might be a smart idea. One of the problems we've encountered back then was that the folks maintaining the Chromium browsers were not really thrilled about taking our patches So we even said to them, you know, it would be fine if you wrote the patches, but you have to get this into your tree because there's no way for us, you know, 5 people back then working on Tor browser-related things to keep up with, you know, several hundred of browser engineers you have at your disposal. There's no way to do that. It's even hard with the cooperation from Mozilla we got over the years because they have had different dedicated engineers helping us with upstreaming our stuff and getting the whole idea of fingerprinting and tracking the systems on their roadmaps. I mean, it's not just writing a code, but you have to get the whole organization aligned to this idea of supporting this way forward. This was pretty hard. So, yeah, ideally I would see someone having a Chrome-based browser on par with the stuff we have right now. But unfortunately, I don't see an easy way to get there because just of lack of resources and of interest from relevant parties. I think this hasn't changed over the years, unfortunately. But there is no ideological sentiment saying you're not Google-based stuff or something like this. We would like to have that, but it's just a ton of work and nobody has the resources they want to put in this.
I think maybe to add something there, I used to work on browsers a long time ago on the WebKit project in my early days of my career, and seeing what we crunch out with the browser team we have with browsers is a huge business today, right? It's something that we see in EU legislation. We see Apple trying to block everything with their game with Safari and arguing about the security properties on iOS and so on. You see Google is investing so heavily in the engineering teams behind these things. We see Mozilla unfortunately struggling quite badly, right? They're trying to scout the area through different funding models for which they can get more funding and stay competitive, right? And sort of the actors they're up against. There's an interesting thing with I have a previous colleague from the Qt WebKit team, Andreas Kling, who's now building his own browser from scratch, right? And there's people sort of following him. I think he does some streaming and so on. I haven't paid much attention to it. But it's these kind of things that potentially can ratchet some things forward. I'm not saying that his project is going to be successful, but it is, if people start building engines from scratch, that could be interesting down the line, but it's many, many, many years down the line if it is to become relevant for us and for the team size that we have.
And to add to that one, another question would be if the Tor project is the right project for doing a browser. You know, you are probably should be more concerned about the network and the client you have. You should, ideally, from my point of view, you should not get in the browser business because the browser vendors should get their stuff done, you know, their privacy stuff and so on, and then everybody would be happy. But what we had to do in the past was picking up their job in addition to our own job, basically doing a browser because they were not fixing their browsers the way they should regarding privacy and so on. So I would argue even that we should not be in this business at all. You should focus on the Tor stuff, and they should focus on their private browser stuff. They can do this better anyway, and they have way more resources than our 5-6 browser people.
Other questions? Otherwise, we're around the next couple of hours and also some of tomorrow.
Excellent. Thank you very much, gentlemen.
You're welcome. Thank you.